Okay, class, in this lesson we're going to learn how to do transformations on polynomial functions. Actually, this lesson in some ways is a review of what we've already learned before. We're just going to be applying it toward polynomial functions. So as a review, we had three different types of transformations: translations, reflections, and stretches, shrinks. They could be done in a vertical manner or a horizontal manner. So if we were doing a vertical translation, the mapping would be xy goes to xy plus k. If we were to do a horizontal translation, it would be x goes to x plus h, and y, the y value stays the same. Our mapping rule for reflection, now when we do a vertical reflection, what we're doing is we're flipping it over the x-axis, so the y value becomes the opposite of what it was. The x value stays the same. It just flipped over the x-axis. For horizontal reflections, we're flipping the function over the y-axis, and in that case, the x value will change. It will become negative x, but the y value will remain the same. For stretches and shrinks, we have vertical stretches. The y coordinate value is multiplied by this a factor, the stretch factor. Horizontal is the same, but instead of the y coordinate, the x coordinate is being multiplied by this value a. Now we have function rules for each one of these as well. For translations, f of x plus k is our translation rule, where we're moving up the function by k. When we want to move the function to the right, we apply the x minus h inside the function. To get a reflection, you can see here from the mapping rule, minus y, so minus f of x. For a reflection horizontally, we need to do it on the inside of the function f of negative x. Stretches, vertical stretches, we're multiplying the output times y, or by a, so a times the function f of x. And then for horizontal, 1 over ax gets fed into the function. So you see here, kind of the takeaway here is that here we're working kind of outside the function. But in the case of horizontal translations or transformations, we're doing things inside the function. And there's kind of this opposite nature. Opposite nature to things where in the mapping I'm multiplying by x, but in the function rule I would divide by a instead. In the translation case, I'm adding h, but to actually achieve that inside the function, I do the opposite, x minus h. We're going to apply all this. We've learned this before. We're going to apply it now to polynomial functions. Okay, as we look at degree 3 polynomial, cubic, let's see how this function g of x has been transformed. We see here, outside, this is the vertical translation, down by 2. And inside here we have a plus 3, which means a left translation. Our h value here is minus 4. That means to the left by 4. Here's another example here. We have a quartic function, x to the 4th. G of x is minus 3, x to the 4th plus 6. So here we see that we're multiplying times 3. That's a vertical stretch by 3 times. We're also multiplying by negative here. That's going to flip it upside down, reflect it across or over the x-axis. After that, we're adding 6 to it, and this means a 6 upward translation. Okay. Here's an example where we're going to take this function described here, and we're going to perform the following actions on it. We're going to do a translation to the left by 1. We're going to do a vertical stretch by 2x, and we're going to do a horizontal, actually let me fix this, horizontal stretch. Stretch by a factor of 4. So, My first rule. First thing I want to do, a horizontal translation to the left. So I do that because it's horizontal, it's inside. X plus 1. So f of x is equal to f of x plus 1. So now I'm going to input x plus 1 into my function here. This is my function up at top. I'm going to put x plus 1 into the x. I'm going to put x plus 1 into this other x value here. I'm going to multiply this all out, and as I do this, what I'm going to do here, I'm going to start with the x plus 1 to the fourth. I have my Pascal's triangle here. I have my coefficients 1, 4, 6, 4, and 1. Then I have my variable terms, x to the fourth. The pattern here is x to the fourth, x to the third, second, first, and this invisible x to the 0 power. And then my other term here is 1, 1 to the 0, 1 to the first, 1 to the second, 1 to the third, 1 to the fourth. But 1 to the fourth, that's all 1, so this makes it easy to expand out. I also have this term right here, minus 2 times this, and that expanded out to that. I add all the like terms together. I get my first function. This is my function after the left shift. Okay, now I want to do a vertical stretch. Vertical stretch by 2 is done by multiplying the function by 2, multiplying f of 1, this new function, by 2. So that's pretty straightforward. Just multiply by 2, or actually here, taking this function, multiplying by 2. Next, I want to perform a horizontal stretch by 4. So what we're doing here, in this case, a is equal to 4, so I want to take 1 over a and feed that into my function here. So this value gets plugged into each of these x's right here. So plug in 1/4 x, plug in 1/4 x, plug in 1/4 x. Now be very careful here. 1/4, these parentheses are very important. I need to raise 1/4 to the 4th power here. So 1/4 to the 4th power is 1 over 256 times 2. It's 1 over 128. This is my expanded form after all the translations, stretches, and a horizontal stretch. Okay, that's the lesson for today. I have these other examples for you to try out. Make this little correction on your worksheet if it's not. I'll show the answer here in 4, 3, 2, 1, 0. And answers for number 5, and the answers for number 6. Okay, have a good day, everybody.